So I wanted to take a few minutes and talk about something you may not have thought about, but that's the rules for naming ionic compounds. Okay, so we have to work through a system of how these compounds, how we come up with a name for these compounds. And we're going to start with compounds that are made out of just two types of atoms. Okay, so before we get into some specific examples, just some rules. Rule number one is that ionic compounds have a positive ion, a cation, and a negative ion, your anion. Okay. Rule number two is that ionic compounds overall are electrically neutral. This means for every positive charge we have to also have a negative charge. Okay? So, in general, the way these are going to work is you're going to have two parts to an ionic compound. You're going to have a metal, all right, and then you're going to have a non-metal. Oops. Okay, so we're going to start out with what are called binary compounds, that is, just two types of atoms. Not necessarily two atoms, but two types of atoms. Okay, so you're going to, in every ionic compound, you're going to have a metal and you're going to have a non-metal. The metal piece of this is fairly easy to name. It's going to be the name of the metal. So if we're doing this compound here, the metal is sodium. Okay. This element here is chlorine. But when chlorine gains an electron, it becomes not chlorine. We change the ending of the element to IDE. All right, so we have sodium chloride. All right, that's the name for this ionic compound. In this case, sodium is in group 1. It has a +1 charge. It wants to lose one electron, become +1. Chlorine is -1. It wants to gain 1 electron to fill its octet. Okay, so in this case, we are electrically balanced. We have 1 sodium to 1 chloride. Okay, so let's work through another couple examples. All right, let's take, I'm going to do this. I'm going to list a couple metals here. And I'm going to list a couple of nonmetals here. And we're going to make ionic compounds with each of them. Okay. So let's do this. Let's first make this compound. Okay, we write, this is the symbol for calcium, so we would say calcium. This is oxygen, so we don't use, it's not calcium oxygen. We leave off the end, we add in IDE, so we have calcium oxide. All right, now if we want to write the formula, this is the name of the compound. To write the formula, we write the two symbols. Then we have to make sure this is electrically balanced. Calcium is in alkali earth metals. It wants to lose 2 electrons, so its ion is +2. Oxygen is over in group 6. It wants to gain 2 electrons. So in this case, we're also electrically balanced. We have 1 calcium, 1 oxygen. The way we would change the number, well, we'll talk about that in a second, but the way we would change numbers, we'd add a subscript in here. Okay, if we don't write a number, we can assume it's just 1. Okay, but if we just have ones, we usually don't write them. Okay, let's do another one. Let's do this one, calcium and fluorine. So again, we write the name of the metal. We take fluorine, the neutral element, to fluoride. Okay, now let's write the formula for this. Calcium plus 2, fluorine in this case is minus 1. All right, so what we have to do is we have to get balance. One quick way to get balance is to do a little crisscross. Take my 2 down here, take my 1 down here, and that way, in this case, I have 2 atoms that are minus 1 charge. My total negative charge is minus 2. My total positive charge is plus 2. Okay, we wouldn't really write the 1. Usually we'd write this. Okay, so that's the formula for calcium fluoride. All right, and let's do another one. Let's do this one. Okay, take a minute, pause, make sure you go to your periodic table, and make sure you can tell me what the charge for the nitrogen atom is and the name. Okay, so we're going to write the name of the metal, calcium. All right, and then not nitrogen, but nitride. Okay, we write the 2 symbols. Now, calcium is plus 2. Nitride is in group 5. It wants to gain 3 electrons. When it does that, it becomes minus 3 charge. All right, so we're going to do our crisscross game here. We're going to have 3 calciums and 2 nitride ions. Okay, so if we count up our positive charge, we have a total of plus 6. If we count up our negative charge, we have a total of minus 6. Okay, so what this means is we have 3. Every formula unit has 3 calcium ions and 2 nitride ions. Okay, that is the formula unit. Okay, that's the unit that gets repeated over and over and over and over again. All right, I'm going to back up a few steps, and we'll do some more examples with cesium. So we have cesium with oxygen, fluorine, and nitrogen. So again, hit pause for a minute, see if you can get through naming these. Okay, see if you can get through naming these on your own. So we have cesium, not oxygen, but oxide. Okay, we write the symbol for cesium, the symbol for oxygen. Cesium is plus 1, oxygen is minus 2. Okay, so eventually you'll get to the point where you'll see, well, I need 2 plus 1 ions to balance out my single minus 2 ion. Okay, but again, if you don't remember that, just use your crisscross, all right, and you'll get that. So there's our formula. All right, let's do another one. I'm going to do one more here. Yes, I'm going through nitrogen here. All right, so here we have cesium nitride. All right, cesium is plus 1. Nitrogen, as we went through before, the ion of nitrogen, when it gains 3 electrons is -3. Okay, so we need to bring our 3 down, and there's our formula for cesium nitride. Okay, eventually we'll go through some other types of ionic compounds that have more than one atom in their ion, but I think this is a good place to start, and I'm going to pair this with some practice for you. Okay, please work through that practice as well.